আপনারা দেখছেন টকিং পয়েন্ট, সৌজন্যে স্যাপ সলিসিটরস, যে কোনো আইনি পরামর্শের জন্য।
Welcome back. Before the break, we were talking to Dr. Ejaz about his various researches, and he has, through his research, he has 20 patents that have contributed to the development of not only science but also make our life better. Dr. Haq, yes, about this stomach cancer detection.
Yes,
your good work.
This was a follow-up from the Rosetta experiments. I was looking for a terrestrial application, and better if it could be in the healthcare sector. So the Rosetta mission, I was mentioning the ionization of particles, the gas particles, etc. Similar sort of idea. And we have in our guts, in our stomach, a bacterium called Helicobacter pylori, H. pylori. And this is the cause of stomach ulcers, the main cause of stomach ulcers and stomach cancer.
Right.
It is most prevalent in developing countries because of food and sanitation.
And as you were saying, it's not a spice that's causing the problem.
No, actually that was well demonstrated by an Australian physiologist, Professor Barry Marshall, who conclusively demonstrated that it is this Helicobacter pylori which is the cause of stomach ulcers and stomach cancer. Actually, there's an interesting experiment he did on a petri dish. He cultured this bacteria and ingested, he swallowed it, infected himself with this bacteria, and then with a triple dose, 2 antibiotics and a proton pump inhibitor, he cured himself. And then results were published and he got a Nobel Prize for that. So since 1988, there's been a lot of interest in trying to deal with this bacterium in the stomach. And you know, the stomach ulcers are a common ailment in our parts of the world. And even in the developed countries, you know, you've got 30–40% of the people.
Yes, this pace of life, perhaps people are in a hurry, rush, stress and all that.
It is also, it is attributed to this bug, this bacterium. So the way it is diagnosed at the moment is you take a large, it's a large instrument called the spectrometer. You take a sample of the breath, which has natural carbon 12 and 13 in it. You measure the ratio of that. Then you ingest a tablet, a urea tablet, which is labeled with carbon 13. You swallow it, and this bacteria in the gut, it metabolizes it, it breaks it down. It secretes an enzyme called urease, which breaks the urea into carbon dioxide and nitrogen.
Right.
And that carbon dioxide is then the third carbon 13 enriched carbon dioxide. So you take a second test, and you compare the two, and you can find out the level of bacteria you've got in your gut. So this is so ultimately our objective, and we formed a company called Oxford Micromedical Limited.
This is also patented, isn't it?
This is patented, yes. And my other colleague directors are Professor Philip Pruitt and Dr. Grant Morgan, who is also a key member of the Rosetta mission. He had some very fine contributions in the Rosetta mission. So we are trying to, we have advanced a fair bit. We are trying to make a very small portable device, and particularly for the developing countries, to screen people having this H. pylori.
How many miles are we away from finding a cure for cancer? I mean, all sorts of cancers.
There's a lot of interest, a lot of research, a lot of...
This is detection, see, but detection will lead to, inshallah, cure, finding a cure.
Indeed, indeed. Well, it's interesting you mentioned that. I can show you yet another work that I was doing.
Yeah.
And this was together with colleagues at the Medical Research Council at Cambridge, Dr. Paul Cofferino and Dr. Jason Davis at the Chemistry Department in Oxford. So the three of us were the project leads, and we worked on this particular project with our research teams. So this is a transistor, like I mentioned a while ago.
Can you focus on this poster, please? Yeah.
This is a transistor,
Right.
which I described before. That is the gate. You can immobilize some bioentities on it, like a cysteine group, and then you've got a scaffold protein on it. And this protein has another attachment, which is an antibody. So the antibodies are produced by the plasma cells in our body, and they have a Y shape, and they're there to they're used by the body's immune system to fight foreign bodies like a virus or a bacteria.
Right.
So this Y-shaped protein has a particular shape, construct, which is called a prototope, which is like a lock, and an antigen produced by the virus comes and couples to it. And this coupling then changes the electrochemical potential on a transistor. That changes the source drain characteristics, and then we can detect. So for every antigen, okay, like say for prostate cancer, the cells are going to produce prostate-specific antigens.
Yes. Yeah.
And those antigen will be, there'll be a particular antibody. And you can have a library of artificial antibodies called peptide aptamers, which is put on this construct, this scaffold. And the prostate-specific antigen is going to come and bind onto this antibody. And the local electrochemistry, if you like, there's an electrical double there.
Right.
So which changes the potential of the gate, and you can. So the point over here is that every antibody can detect an antigen. And there are thousands of antibodies. And if you use a chip construct like this, which we did, then you can detect thousands of antigens. And some may be cancerous, some may not be cancerous. But you can do the diagnostics in a matter of minutes. We are still some way bring it to fruition, but the possibilities are definitely there.
At least you can detect.
Yes. Yes.
And once it is detected, the next step is to.
And the prevention, early detection. The early detection is key to.
Like in breast cancer and prostate and other
Indeed.
cancers, early detection
Indeed.
is of prime importance, isn't it?
Yes. So we tend to diagnose when it has actually proliferated to a certain extent. But if you can catch the disease early on, then so much the better. And nanotechnology promises just that. And nanoelectronics promises just that.
There is a myth usually common and passed on from mothers to housewives and their daughters, and that microwave contributes to, it's not healthy. And anything that is processed in microwave, heated in microwave, can cause cancer. Is that right?
There is no, I'm aware of the published literature on this. There is no definite conclusion on any of this. At best, the microwave can make some bonds to break in the hydrogen and oxygen in the food, or it can disintegrate some chemicals over there. But I don't quite agree that that there's no conclusive evidence to suggest that it's harmful to the body.
Also that don't stand in front of the microwave cooker when it's on, because it sends out harmful waves.
It is very well protected. It's very well shielded inside. And if you leave the door closed and don't open it while it's running, I think it's really idiot-proof. You can't do that.
Right.
As soon as you open the door, the whole thing is going to stop. It will stop. Yes. So I think those dangers have been taken care of.
Great. It's probably the anti body that starts as a don't use a microwave, use something else, conventional cooking. This is the last segment, and I know that you have been thinking a lot about sharing your research and experience with kids of the Bangladeshi diaspora, and also trying to improve and creating a situation where science and research can actively be used and applied to make our common person's life better in Bangladesh. And you mentioned Dr. Abdul Salam's plan about centers of excellence. Do you have anything in your mind to improve education, research, common life, cancer detection? And
I have not, I'm guilty of not interacting thus far in any meaningful way in Bangladesh, something that I'm definitely not proud of. And if I could, I would definitely like to do that. Mm-hmm. It's about creating the right kind of environment in which research can flourish, advancements can be made, but you need critical mass. Mm-hmm. And above all, you require a vision from whichever the government is. Mm-hmm. Mm-hmm. That we should be we should be engaging in serious science, capacity building. It is necessary for any country to develop. It is necessary. There's a lot of scope, a lot of opportunities, and personally, what I have learned over the years, doing my research in the UK and traveling quite extensively abroad, I have seen China develop over the last 20 years. I had a visiting chair at Sun Yat-sen University for 5 years, so I was going out there and lecturing. Nationalism is necessary, the focus is necessary, and I often think about Martin Luther King, the famous statement that I have a dream.
Right.
I think it applies not just to patriotism and politics.
Right.
It applies everywhere in any discipline. And one really needs to have a dream and follow it through.
Right.
There will be bumpy rides, lots of trials and tribulations, but at the end of the day, the rewards can be immense. One has to be patient and really persevere.
You have to have a dream.
One has to have a dream.
Would you like to say something to our younger viewers who I'm sure that are watching, and they are watching in awe about so much of good work that you have done in your life in such a short time?
I think the only thing I can say is that, be focused, have a dream, and there will be challenges, but pursue them, whatever it might be. Mm-hmm. It doesn't have to be science, it doesn't have to be technology, it can be, studying a plant leaf for. But if that is your passion, fix your target and drive at it.
Right.
And you will get there.
It was a great honor and a pleasure to have you, to host you on our show.
Thank you very much.
And on behalf of NTV and on behalf of our technical team, I thank you.
Thank you.
It was a personal pleasure.
Thank you. Thank you very much.
Thank you very much.
Thank you very much.
Thank you, viewers, for being with us. Professor Ejaz Haq is a well-known name in the field of science and technology and research. He is a visiting professor at so many universities and also at Queen Mary University, not very far from here. He has 3 research works being carried on under his team. And he has written about 150 or 150 research papers. And we hope that the number will go on and he will continue to make further research, further inroads, and probably as he is into cancer detection, one day we will find the cure for all kinds of cancer. Thank you very much for being with us. I hope you have enjoyed the show as much as we have. Same time, same channel with another distinguished guest. We'll be here next week. Thank you.